So, what I first wanted you to think about was, okay, standard form versus factored form. Here I gave you something that was in factored form. What do we call it if we want to go from factored form to standard form? What do we have to do? Okay. What is the word you're saying? Okay, what operation is right here? Multiplication. Multiply. And what is it called when I have to do this? Distribute. We have to distribute. Okay. So, Miles, when we distribute, what do we get for standard form?
Like 24 is the third plus 8 is the second.
Okay. And if we set each of these factors equal to 0, Vivi, what do we get?
H equals 0
And negative 1/3. Okay. So I know this came up in your homework. Like there was one of your homeworks that you had, and I'm not even going to remember it right. But maybe you had like r minus 4 squared times r plus 2, something like that. Okay, so do we agree that r equals 4 and r equals negative 2? This square means technically that root is happening twice. Okay, you don't have to write r equals 4 twice, but it technically is happening twice. And that's something that will, like, when you're in algebra 2, you will use to help you graph it, okay? But if it happens twice, it's okay. We're not going to write it that many times, okay? So technically, like here, we have h equals 0 happening twice. That's fine, okay? Okay, and then I made you think a little bit. What if we have to go from standard form to this factored form? So who feels really confident in what goes right here? Okay, Joey, I'll come back. Joey, what did you put there?
We put 6x times 6 times x to the first.
Okay, and
And
then,
then plus 12.
okay.
Also, for the standard form on number 2, wouldn't that be h to the third? Because the 1 has to pick one, the 1.
Huh? Okay, okay. So, somebody that's not Joey or M. Why the 6x, Theo?
Because it's 6x squared on the outside. That's all I found.
Okay. But why did you choose 6 and x? Why not 2? Why not? Oh, did you guys hear that word? Don't we say it again? Ah, this is the greatest common factor. Fun stuff. So if we have 6x times x plus 12 equals 0, do we get x equals 0 and x equals negative 12? Yeah. Okay, so I'm going to use Dot's choice of words here. Greatest common factor. Aaliyah, what is the greatest common factor here? 7. 7p is what you have written down. 7p. And if we factor out 7p, what is left? Minus 3. Okay. So we have 7p times p minus 3, which means p equals 0 and p equals 3. Okay, if you don't have this written down because maybe you are a little stuck, could you fix it? okay, to look like what I have. Okay. And if maybe you were a little stuck and you didn't have what we wrote down in row 3 and row 4, I'm going to give you a moment and adjust your row 5 if you think you need any adjustments. So you and your elbow partner, talk now. Do we need to adjust row 5? If so, how? Ready, set, go.
I did all the
So it's actually, since there's not an H, it's like 1 H to the 0.
Okay.
Does that help?
So like if it doesn't have a variable.
Yep, we can't. Yeah, it's that variable to the 0. Okay. Okay, let's circle back. Emily, what do you think about our greatest common factor in row 5?
Yes.
Ooh, 15. And then any variables to go along with that? Ooh, 15F. And if we have 15F in common, then left over, how do I figure out what's left over? Like, how are we getting these mystery numbers right here? Okay. Theo, how would you explain it?
So you divide negative 45 by 15, and there's also 3 F's left, or 3 exponents of F left, so you put F cubed minus 3.
Okay, so if I take 15F and I divide each of these by 15F, then here left over is just F cubed, and here left over is just minus 3. Do you see how they did that? Okay. Are you angry over there?
Yes.
Why?
David messed me up.
Ooh, and oops, Mrs. Homan. We're not going to worry about solving there because... How about this? If you solved it, F equals 0 and the cubed root of 3. I overlooked that one. Sorry about that. You're not going to... yeah. No. I promise it would be the cubed root of 3. Okay, but I got really excited and didn't think about that right there. So don't worry about that one. Okay, this is what I want you to do. You're going to help me with our notes. We're going to go back to our notes on page 223.
You can have it. No, I don't want it.
It's like a list. You can add more buttons to your fidget. Add like a flipper. I never said that I don't know how to pronounce it. And then, like, it's like little pieces from like
Okay, so our goal today is to still solve given factors, okay? But this time, like you saw in that exercise, we're going to have to do a little bit of work to get there. So thank you, Dot, for remembering that it is called the greatest common factor. And I am going to call it the GCF for short, okay? I am going to give you problems that will require you to factor out the GCF in order for us to write them as factors. Okay? So that's the first thing we're going to practice. Notice how in these 13 through 18, they are not set equal to 0. Okay? We're not going to do that step. We're just going to rewrite them. Okay? So think in your mind, silently, in your mind, what number and variable these have in common. The greatest common factor. What can we divide out of both terms? Rachel, do you have an idea? 3. I like 3. 3. Any variable that they have in common? One what? Y 17. What variable do they have in common? Ah, there it is. 3x. Okay, so if we divide out 3x from 6x squared, what's left? We need an x. What else? Basically, I'm asking you 3x times what is going to get us 3x or 6x squared? 2x plus 1. Okay? This is what you need to be able to do. You need to be able to distribute that GCF back through and get what we started with. So is 3x times 2x 6x squared?
Yes.
Is 3x times 1 3x?
Yes.
Okay.
I know this may be off where I did put down 6 just by itself and then x to 1 and then plus 1/2. But
No. I don't want fractions. Yep. Okay, now, how about 14? 14's a little different because we have lots of y's happening here. So first of all, let's focus on the number. What number can factor out of both 4 and 20? 4. Okay. How many y's do we have in common? Y to the
3.
third power. This one's y to the fourth. This one's y to the third. So we know that they share 3 in common. Okay, so if we factor that out, okay, remember we want to be able to distribute and get back to where we started. So what would we need here to get back to 4y to the fourth?
1.
Or just y by itself.
1y. Yep, 1y. Minus, what do we need to get back to 20y cubed? 5. Connor.
No.
So since this is y cubed, you know what? It's okay. All right, how about you look at 15 and 16, see what you can come up with. Okay? 15 and 16. Okay, I will accept it. You can go and go. Miles, can you tell me what you wrote down for 15?
-6u and -3u squared plus 1.
So this is what I'm going to have you do. I don't want you to factor out the negative. Let's just call it 6u. And then that way we have 3u cubed minus 1 in parentheses. It just looks a little bit nicer that way. Okay? Are you okay with what Miles and I came up with? Okay, Joey?
I kind of have one, but it may seem a little out of whack. So I'm gonna try my best. I had a negative 6 times a negative 3 to the 4th. So essentially, I'm guessing about 6 times the exponent of a 1.
Right.
That should be then the exponent should be a 3, and that gets you a positive 18. And then I just put a plus u, or that could just become a 1.
So I want it to look like this. I don't want you to worry about a negative GCF. I want it to just be a positive GCF. Okay? Okay? That will simplify our life a little bit. Okay? Okay? Now for 16, 16's interesting. Is there a number that those two have in common? No. So we can only factor out z to the 6th. Left over is 7z plus 2. That's what that should look like. Okay? That is what I want. Yes. Okay? Now, what is nice is when we get down to here, these ones that are solving, I think the GCFs are a lot easier to find. Okay? So, like in number 19, what's our GCF? 1K, right? So we don't have a number other than 1. And then if we look at our variables, they have a K in common. So we can factor out a 1K. Left over would be 6K plus 1. Okay? Now we're going to go the one step extra. What we learned yesterday. If I have two things multiplied together that equals 0, well, then we can say K equals 0. We can say 6K plus 1 equals 0. Okay. So this means K equals 0. What does this mean? Negative 1/6. Okay. Now, if you're really nervous about that, we could check our work by coming up here and saying, okay, is 6 times 0 squared plus 0 equal to 0? Yes or no? Okay. Is 6 times negative 1/6 squared plus negative 1/6 equal to 0? If you do the math, then yeah, that is. You have a calculator. You could probably do that in your calculator. Okay, that could be a way for you to check your answers. Okay. Ooh, I like this one. Number 20. Think about the GCF. Think about it in your head. Some of you are already doing it. Whisper it to your neighbor. Do you think it's this? I hear 7, but 7 is not the only thing you need. 7N. Well, those are some scary whispers. Some of you would be a little bit creepy to run into whispering like that. Okay, what's left over? What multiplies to 7N to get us 35N?
5.
Minus
7.
7N. Okay. So either 7N equals 0 or 5 minus 7N equals 0. Okay. If I solve for N here, we get N equals 0. If I solve for N here, I could subtract the 5 and then divide by the negative 7 to get 5/7. Okay, before I decide if I'm done or not, I want to look at the bookwork. 25. Okay, real quick. What if I want to do a problem like 22? That doesn't look the same.
Would you just do, well, first of all, we cannot just do divide because they're not like.
We cannot divide, but what could we do?
Because
Vivi, what do you think?
Could we like subtract from a side? Add or subtract? Could we add 70? Yeah. Could we add 2x to both sides?
Okay, so could we add or subtract so that we have 0 on one side? That's exactly what we need to do. So since we have minus 72x, we can add 72x over. First of all, now we have everything on one side. Second of all, now we have equals 0, and that's going to be important so that we can do the zero product property. Okay, so, ooh, interesting. It's like you've seen this one before. Look at your paper.
oh yeah,
Didn't you see this one on your paper?
it's gone.
It's gone. Ugh. What's the GCF?
The GCF is 6.
6x times x plus 12, right? So x equals 0 and x equals negative 12.